Hello, welcome to the last part for today. Let's look at a real world problem here, please. Problem number 4. It's on the last page of your notes, and let's read it together here. It says there is an architect who uses software to design a ceiling. The architect needs to enter an equation that represents a new beam. The new beam will be parallel to the existing beam on the graph over here. And the new beam will pass through the corner at 0, 10. What's the equation in slope-intercept formula that represents the new beam? Something that this is basically how a computer could be used to figure this out, and you would just have to design the computer to be able to read the coordinates and calculate the angles based on this idea here. So here is where the existing beam sits. They want a new beam to go through this point right here, based on this drawing that the architect made, and then they overlaid the grid. And then they know it says use the slope formula, so they're going to talk you through it here. What we need to do is calculate the angle of this beam relative to this room. So based on these coordinates that we have, well, one way that we could do this is we could realize that, well, I know the beam goes through this point, which is 0, 8. And I know the beam goes through this point right here, which is 12, 0. So we have 2 points that we can now calculate the angle or the slope of this beam. Okay, so let's use our slope formula. Y, I'll use this 8 here as y, minus y would be 8 minus 0. Okay, change in y divided by change in x would be 0 minus 12. 8 minus 0 is 8. 0 minus 12 is negative 12, and if I reduce that down, I get negative 2/3. So this represents the slope of the angle of this beam right here. But what we want is, we want the beam to go through this point. So first thing we want to do is realize that the beam, if it's going to be parallel to the existing beam in number 19, in order for the new beam to be parallel, the slopes must be the same, because it's parallel, not opposite reciprocal, that's perpendicular. So now find the equation of the line that will be parallel through the existing line and pass through this point. Well, I know that the slope is negative 2/3 of the new beam, but I also know that the y-intercept, which is b, is equal to 10, because it's right there, 0, 10. So the equation that we could put in the computer would be y equals negative 2/3 x plus 10. And there you have it. Okay, used all the information that we just learned earlier in the previous video. So let's do a last check for understanding here before we stop the video. How is determining if 2 lines are parallel, similar, different if they're perpendicular? How is the process different? So how is it the same? How is it different? Number 21 says, to determine if 2 lines are parallel, what do you need to do? Okay, well, the first thing you need to do is find both slopes. Find both slopes. Okay. And then determine, are they the same? All right, to determine if 2 lines are indeed parallel. Number 22 says to determine if 2 lines are perpendicular, what do you need to do? Well, same thing, find the slopes. And then determine, are they opposite? Are they opposite reciprocals? Okay. Well, how are those two processes similar? Well, must find slope in both. This is just a review part here. Okay, so those two processes to determine if it's parallel or perpendicular, you have to find the slope. It's kind of the point of the whole lesson. How are the processes different? Well, the only way that they're different is the slope requirements. The slope requirements are different. And that should wrap it up. I think that's really all we need to cover in this video here. So bring your questions to class tomorrow. We'll go over it and you'll have a little bit of work to do. All right, later.